Welcome back to Think Thrice Problem Solving. We're solving a fun little problem today. So we want to find all values m and n that are in the natural numbers if m squared plus 2004 is equal to n squared. All right, so if you'd like to give this a shot, go ahead and pause the video. Otherwise, we're going to jump straight into our solution. So when I'm solving this, the first thing I'm going to do is I'm going to try to isolate my 2004 here, because this looks like a number theory problem. So I'm going to get 2004 on the left, and that's going to be equal to n squared minus m squared. And if you've done a little bit of math in the past, and you've done some problem solving, this is going to jump out to you right here. We have n squared minus m squared, which is the difference of squares. That's going to be n minus m times n plus m. Okay, so we're going to have n minus m times n plus m. So as we're working through here, this is going to help us out a lot. So we have one number times another number is going to be equal to 2004. So that means that n minus m and m plus m must both be factors of 2004. So let's break down 2004. So this is going to be 1002 times 2, which is going to be 501 times 2, which is going to then be 3 times 167, and 167 looks to be a prime. Yes, so 167 is a prime. So our prime factorization of 2004 is going to be 2 times 2 times 3 times 167. So since I have 2004 as my product here, and I have n minus m times n plus m, we're taking these two values right here. And what do I know about these two? So either n minus m and n plus m are both going to be odd, or n minus m and n plus m are both going to be even. And since 2004 is even, that means that n minus m and n plus m are both even, which means they're both going to have a 2 in them. So what I'm looking at here is if I have 2 in one number and 2 in another, how can I make these values? So I know n plus m is going to be bigger than n minus m. So I could have n minus m is equal to 2, and n plus m is equal to 2 times 3 times 167. So that is one solution. So we'll call that solution set A. I could also have solution set B, where n minus m is equal to 2 times 3, and n plus m is equal to 2 times 167. And since I'm restricting myself to n minus m is less than n plus m, because they're both natural numbers, that means that these are going to be my only two solutions. So there's no other way I can use these prime numbers right here to get another set of solutions. So all I need to do here is I need to solve these two systems of equations. So if n minus m is equal to 2, and so this is situation A, and n plus m is equal to 2 times 3 times 167, which is 1002. I can just add up these two equations, and I'm going to get 2n is equal to 1004. So n is equal to 502, and that would make m equal to 500. So one of my solution sets is going to be nm is equal to 502, comma 500. If I look at situation B, I have n minus m is equal to 2 times 3, which is 6. And I have n plus m is equal to 2 times 167, which is going to be 334. If I do the same thing here and I add up these two equations, I'm going to get 2n is equal to 340, so that n is equal to 170. That would make m equal to 164. So my second solution is going to be nm is equal to 170, 164. And it turns out that these are going to be my only two solutions to the above equation. Okay, and if you enjoyed working through this video, please like and subscribe. If you have your own problem that you'd like me to solve in the future, please go ahead and submit it, and I'll work through it at a later date. Otherwise, as you're working through problems, think once, think twice, and if you get stuck, think thrice.